So, hello, this is a rather inconvenient bar right here. So, my name is Dundas. I'm going to talk about functional reactive programming, specifically with ReactiveCocoa. I've put the slides on Twitter already, so there's no need to take notes. You can download them if you want at the end or whatever. First, a disclaimer. I'm not from a functional background at all. I can't write Haskell. I'm just going to talk about my experiences after watching Ash Foro's talk last year at NDevCon, where he talked about ReactiveCocoa really passionately, and made me want to check it out. I bought his book and then got really into it, and ended up writing a client app for it at the end of last year. I think it's really awesome, so yeah, I'm going to talk about that. I'm going to talk about the problems of imperative programming, which is basically object-oriented programming that we do now, conventional programming. I'm going to talk about how functional reactive programming addresses these issues, and then the majority of the talk will be on ReactiveCocoa, which is an implementation of functional reactive programming. If anyone wants to ask any questions at any point, just stick your hand up. Yeah, imperative and object-oriented programming is basically, if we think about it, basically just telling the computer step by step what it needs to do. So you're just writing like, if A and B is true, then flick this switch, pull this lever, redraw the screen, and if you write the instructions correctly, then hopefully the computer will display the right result. When we code imperatively, we like to write lots of little post-it notes around our app, which is basically keeping lots of state. So, for example, set constant to 200, set enables no, is syncing no, overlay showing yes, user is active yes. And then this goes almost without saying, x equals 1, y equals 2. So if z is x plus y, z is 3. If you set y then to 4, z stays at 3. Because you already said it's 2. So this is the state of imperative programming. And the main point is that the more features we add, the more the complexity of our app balloons as we try to make sure that every time we add more state, and then when we change things, we find it harder and harder to maintain a consistent state in our app. Because we have to, with every extra feature, we have to then update, make sure we've got everything in sync, blah, blah, blah. And that leads to edge cases and bugs. So ReactiveCocoa comes from the world of functional reactive programming, which is kind of like, this is a quote that I took from my podcast, kind of like a paradigm shift on top of a paradigm shift. It's functional programming with reactive programming added on top, which makes it intimidating because it's a big change from what we used to. I wrote that word for word. So first I must explain what functional programming is and what reactive programming is. So from 1,000 miles high, functional programming, you can distill it down to an abhorrence of state. Basically, we write functions that take everything they need as input, and given the same input every time, they will return the exact same output every time. And the key point is that they don't query the surrounding system for extra state. So you're really just thinking inside that function. Similarly, you don't have any side effects from running that function. So if you call that function once or 10 times, it doesn't make a difference to the surrounding system as a whole. And then the third one is immutability. So which we have in Swift now. Once a variable is set, we can't then change that. We can only transform it to a new value. So the downside of this is that in the real world of imperative programming, we find side effects useful. That's how we can display to the screen, and how we can. It's how we can take user inputs, which can be like fuzzy and very, unpredictable, and so what we're trying to say is that we're trying to show the computer what to do and not how to do it when we write functions. And then reactive programming is where we, so going back to the best metaphor for reactive programming is a spreadsheet. If you have x is 1, y is 2, x plus y is 3, but then we change y to 4, then in a spreadsheet, then what is
Sorry about that.
Brilliant idea. I
Seriously,
see.
guys.
Next time we get chips,
I
right?
thought they were melting, so I thought I'd just pass them around.
Oh, it's melting.
I didn't know they would make this much noise.
They were changing states, so we had to move quickly.
And the side effect was
Right. So x is 1 and y is 2, and then z is x plus y. Then z is again 3. But if we change y to 4, then z is then updated to 5, because we say that z reacts to the changes of x and y. So this is kind of key to the reactive programming paradigm. So functional reactive programming. You can think of it in terms of you transform your input to produce output continuously over time. And this sounds a bit abstract, but you'll see what I mean in a minute. The over time bit is given to us by the reactive paradigm, where as you like you change it, you set the variable to something and then something else, and then it's hard to explain that. But anyway, that's what allows us to mix functional paradigm with Cocoa, which is inherently imperative, because it has all kinds of state, like I showed you in the slide before. So anyway, so signals, which you can think of like pipes, and like pipes, they send things, they transport values, not water, and these signals can combine and transform the values as they pass through. But like pipes, they don't actually, you don't see what's going through them while it's going through. And signals are at the core of functional reactive programming. So, I'm going to take my spot in here.
Striptease.
So you have the signals, and they can So a signal can basically send next value over and over again, which we can subscribe to. So in our code, we have a signal. We can just say that we want to be informed of each next value as it comes. And the signal can also send once a completed or an error value, but not both. And once you've sent those, you can't then continue. The signal closes itself down, the pipe closes. So we can subscribe to receive these values from the signal, and then we become a subscriber. I really like this model because it separates out processing of values, the regular processing of values, from the exceptional states of having finished and the error state. So it forces us to really handle those separately and keeps our code quite clean. So that's all very abstract, and it will make a lot more sense when I show you some code examples of reactive Cocoa. So what is reactive Cocoa? It's an open source library that brings functional reactive programming to Objective-C and to Swift with version 3. It was created by Josh Abernathy and Justin Spar-Summers while they were developing GitHub for Mac. Like you do, you come up with this new library. And yeah, it combines functional aspects such as telling the computer what to do and not how to do it, and passing functions and blocks as objects. And the reactive aspects of reacting to changes and having data flows. So this is how you create signal in ReactiveCocoa. So imagine we have a string property called first name. Then we can, with this wrap observe macro here, we can say that on self, which is where first name exists, we want to create a signal of changes to the first name property, and yeah, then we just so this macro returns a signal that fires whenever first name changes. And this is how you subscribe to the signal. And it's going to become clear why this is useful as we add more layers to it in a minute. What do we do here? Very close to it. We have the same macro to create a signal from first name, and then we add, after it, subscribe to the next value, the name of the string, and then we just log that that variable was updated. And whenever that changes, that will get called over and over again. So it's kind of like KBO, except without add observer, remove observer, did change, etc. So we're already replacing KBO at this stage. KBO is key value observer, right? Which I'm not going to explain because I've loads of it's magic. So what we can do with these signals is we can append signal operators to them. So for example, map. Say we have a Boolean property called isLoggedIn. We can create a signal from it, and then we can add, before we subscribe to it, we can add a map operator where, and there's automatic mapping between primitive values and objects here. So, because, yeah, otherwise. So what we do is we have a Boolean coming through, and what we return out, what we transform it to is a string. So it goes in as a Boolean, comes out as a string. And if it's true, we return logged in. If it's false, we return logged out. And then here in the subscribe, we get past the string, not the Boolean, which we then log. And then we, in the subscribe next, we can have what are called side effects, which we don't do in the operators, but we, in the subscribe next blocks, we can do things like then change the, call out into the imperative world and refresh the view. So yeah, that's what I should say. Is that a side effect is emerging from the purely functional to the imperative to achieve some real world effect. Another example of a basic signal operator is filter. So in this example, we have a property called username, which is a string. And what we want to do is, we only want to be informed of changes to that value if this block here is true. So we do a test to see if new name, the length is greater than 4. And if it is, then the filter will allow the signal to pass through to the subscribe next. And then we get the NSLog, the name change to this. But if it doesn't prove to be true, then it just doesn't happen. It stops it at that point. And so these signal operators are building blocks that you can use to build up more complicated functionality, as I will show. So this is the most powerful part of it. This is kind of being academic so far, but this really is how we can use it in our app. So this, so again, we're creating a signal here that tells us about changes to the first name property. It sends a new value each time that changes. But what happens here is the text property of our label is automatically updated when this string changes. So we're binding the string to update a label whenever this changes. That makes sense. So it's kind of like KBO, but really condensed. And then if you think about if you can combine these with signal operators that kind of shield changes to this until they are true, then we can begin to build logic about when this label should be updated. So the third signal operator I want to show you is combine latest and reduce. Combine latest to reduce, which is one approach. So say we had, and I'm going to show you in a sec, but say we have two signals, say one for username and one for password, that are being updated separately. They go in, and out comes this is a block here, and then out comes the combination of those two being merged, which could be a Boolean or whatever we want. I'll show you in a sec why that's useful, but you combine the latest values and then reducing them down to one thing. So these can be like, this could be 3 or 4 signals, but the key thing is you reduce it to one output. So this is useful for waiting for conditions across your set of inputs to be met before allowing an output, for example, or for deciding between the inputs to allow one of them through. So it's a way of combining the signals and allowing one through. Or ReactiveCocoa comes with some Cocoa extensions to produce these signals for us without having to, so for example, we have a text field here, and we can take a signal from it immediately that tells us about changes to that text field, which I think is a nicer interface than using the traditional text field bit of day characters with range, blah, 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 delegate callbacks, which is really messy. So we immediately get the signal from that here. We also take, in the combined latest, we take the password as well, and then we have some imaginary login manager that has a Boolean property on it, which is called logging in. And we're creating a signal at that point, so that it's going to tell us if it's true or false. And then we're reducing it into, this can be an arbitrary length of input parameters. So we've got username, password, logging in, and then we call it should be enables. This is a Boolean, and then we return back. So we're creating, yeah. It's hard to see the screen. So we've created this signal, which is here now, and that we bind that to the enable property of a login button. So using this logic here, which is in the signal, we're binding the enable property to that. So this logic will set the login button to be enabled once these are true. Am I making sense so far?
Yeah.
Okay, good.
So, can I ask a question?
Yes.
So here, the two blocks don't have any side effects at all, right?
Yeah.
The only side effect is in the binding of the logic.
And the binding, you can also do the subscribe next. So you could put a subscribe next onto this to also receive the booleans and like NS log them or whatever. But instead of doing that, we can just immediately bind it
to a property.
Yeah, tightly. So the key point is we don't take any account of what's happening outside the function. Because functional programming reasons only about the input parameters. So it makes these, each piece of it is very simple. It's just like you're just making a boolean and returning it. So by chaining, combining, and reacting to signals, software can be written declaratively without the need for code that continually observes and updates values manually. I'm going to talk about derived state, which is a core concept in functional REST programming. So I said before that keeping state in variables is bad, but ReactiveCocoa makes a compromise that state is okay as long as that is bound to a signal. So as long as we're not changing it manually ourselves, then it's okay to use state. And that's how we then interact with Cocoa, because that kind of requires us to talk in imperative terms. But as long as when we do that, it's kind of bound to a signal, then it's okay. So yeah, you never explicitly set the value of a bound property, but you rely on signal transformations to derive that state for you. So getting started. Replace KVO with ReactiveCocoa. So here is KVO, which is like, I don't know, 20 lines or something. View the load, set up the observers, and then this is the only reason I think to keep a dialog method in your view controller, is to tear down the observers. And if we forget to do that, the program crashes. So it's very, and there's no way to query to see if we need to remove our observers or not. So it's quite a shaky API, because if you get it wrong, the program crashes. So replace this with this instead. It's just exactly the same thing. We're just observing the first name and then subscribing to changes on it. First name and change, exact same thing. In addition, ReactiveCocoa manages its own memory under the hood. So you don't need to keep reference to these things. It kind of does it all internally. And also, the last thing is we have a block-based API now instead of Delhi callbacks. And if you start doing only this, it won't be long until you start adding maybe a map function tucked in between here to like change the string into a number or a color or something like that. And then maybe you'll be filtering things. So that's a good way of getting started. So what are some cool things to do? It would be otherwise hard. Throttling. So what a throttle signal operator does is it won't let the value through if another value follows it within a certain amount of time. So say we set the time frame to 1 second. If we have a value come through and then nothing happens for 2 seconds, we let that value through. But if a value comes through and then half a second later another one comes, we throw the first value away and then start the timer again. So this is kind of good for if you have a search field that does some network calls as the user types, like Google basically. You can, if they type it fast, you just throw away the previous. You don't even need to like start up a network request at all. So you can imagine what it's useful. Tape until. We allow a signal to pass through until another signal fires, and then that stops the signal being allowed through anymore. So it's a pipe, but the second another signal is also bound to it happens, you kind of turn the tap and it stops letting anything through after that. It's all very abstract, and I didn't want to do too much code, so but the documentation for ReactiveCocoa is really good. So it's more about trying to get an idea of what you can do without how to do it. And deliver on. We put in our chain of we attach to the end of our signal to say deliver on the main thread, because normally these things happen on background threads, so that's like a positive thing. It doesn't block the main thread while these signal operations are happening. But then before we do some update of the user interface, we can call deliver on and then pass in the main thread. So this is going to be a crazy example, and if you don't manage to follow it, that's fine, because I wouldn't have been able to follow it probably to start with. But I just want to show you what's possible in a very small amount of space. So it's just to give you a flavor of how complex functionality can be condensed down to a readable signal chain. So what we're going to do is we're going to have a text field that we type into, and as we type, it's going to do a search for Twitter and give us the tweets back that match that search. It's like a type ahead functionality. So the first step is we request access to Twitter as a signal from the OS. When that signal completes by asking the user blah blah blah, we throw that signal away, and then with the second line, we put in the next signal instead. So and the next signal is a search text fields wrap text signal, which I showed on one of the first slides. It's just a signal giving you updates about what the user's typed into a search text field. And that will be the basis of what goes on after this. So then we filter out anything that's not valid search text by just calling some method that passes text, and if it's true, then we allow the value to continue. If not, then we don't. We throttle it. So if we receive another text entry within half a second, then we throw away the first value and continue, and then prioritize the second one. Right? Like I was just saying the problem before. This is complicated. This is what I was talking about as being complicated. Flatten map. So what you've got here, an input is text, which has come from the text field above, and it's come through the signal, blah, 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 and we have text here. But what we do is we call off to another, and you can't see it, chain of signals with that text. And that does the networking, and it's still ReactiveCocoa, but it's kind of, it's off-screen, it's abstracted away because we just have this method called it. And what this does is it returns the signal, which is doing that. And then we flatten and map, which is the operator I described before. We map that signal back into the chain, and that will be continuing. So the result of this is what we return as the next value. We deliver it. Sorry, so the result of this is a dictionary, JSON search result. We map from all the search results. We only want this subtree of the JSON. We just want the status. So we return that, because we can just throw the other stuff just vanishes. We deliver it on the main thread, because we're about to update the UI. And then we subscribe to the next value that reaches this point. And then just say self display tweets, and we pass in the array, which is from here, the array of tweets. And errors bubble down. So if any of these return an error, so this here could return an error, there's no data available or whatever, that will all bubble to here with an NS error object that tells us what the problem was. So all errors bubble down, which is really useful. So, before we so far, at first, none of it made any sense to me. I spent the next week poring over the ReactiveCocoa docs, but no matter how much I read, signals, etc., they were all just words to me. It wasn't until I dove headfirst into the code that I started to see the light, which I really think is true. And I put as a speaker note, consider changing this to a more optimistic quote. I think we made it so far. And then, lastly, try it. So it's definitely a bit intimidating to start with. Once you learn the different rules about what the different signal operators can do, I actually think the code becomes easier to read than it was before, and the program as a whole becomes easier to grok. Right? The contents of the operators individually are so concise that you can just, they're like usually one line. You can just read you can really get an idea of what's happening. For example, like filter this out, now map it this way, like transform the value to now be this. Now combine it with this other well-named signal that tells us what is actually happening. And what I haven't really shown is there are ReactiveCocoa APIs to wrap blocks, delegates, notifications, and all that kind of stuff, so that you really have a common interface of ReactiveCocoa, and not all the random stuff that Cocoa has provided us over time. Yeah. And it has powerful threading support as well. So it becomes easier to understand what either you yourself wrote like 3 months ago, or what some other programmer was written. Instead of trying to build up this giant, which is what normally happens with taking on other projects, you have to build up a whole state machine of all these levers and things happening inside the app before you can then start changing the code. And this is because we're telling the code what to do, not how to do it. And this is a value of functional reactive programming. And that's it. Yeah, questions? Oh, I don't know.
So in that example you just gave, the last example you gave, because this solution is really nice to kind of make your threading much simpler as well.
Mm-hmm.
You sort of like insert an array of tweets.
Yeah.
If you sort of like want to sort of like at that point sort of like have it explode in a flurry of signals rather than just an array, is there sort of like a natural way of doing this type of signal explosions or iterations?
You mean to do something on each of those arrays?
Exactly.
Each element
So
of the
you
array.
can sort of like then control how that can parallelize or however you want to do that.
Yeah, so you just you fold. There's an operator I can't remember what it's called to do something on each of those array elements, and then fold the result back in, and you just add it to the chain. And, yeah.
That's good.
Sure.
Yeah, thanks for your talk. Since Swift already is functional, is it working in Swift as well?
Yeah, I think they had. Like I don't know much Swift yet, actually, because I was learning ReactiveCocoa when Swift came out.
Alright. Choose.
Yeah, exactly. And I also use AppCode, and AppCode doesn't fully support Swift either. So Swift is on the back burner for me. They're coming out soon with ReactiveCocoa 3, which has Swift as a first class language. And I think they tweaked it a bit to really make use of Swift and use functional aspects.
Yeah, how do you unit test all this code hell?
Yeah, it's possible. I haven't tried it. If you know about view models, then you can, which is I think I didn't have time to mention, then where you kind of pull a lot of your logic out of the view controller and put it in a separate object, which you can unit test discretely anyway. It doesn't really matter if you've done it with ReactiveCocoa or not, because you're testing the black box. So I guess you can do it that way. But yeah, unit testing, ReactiveCocoa, I haven't done much.
Do you unit test those individual blocks or unit test the whole chain or what?
I don't know.
You can factor out the separate signals, I guess. And
then they become separate functions. And then
yeah, sure.
Whole, like,
But if you unit test them,
well, yeah, no, because if you just don't have the blocks but the separate functions and only use one function per block, then you can test those functions and test the input/output.
Exactly.
And then it's
there is no benefit of having like all of them in place, right?
yes, because it's still readable from top to bottom. Right?
And also, like best practice is usually not to test a lot, because you could see those as internal implementations. Sometimes it's like unit testing. It's useful to like get input and output, and just test that, make sure that's unit testable, like not the specific pieces themselves. So, but yeah, it's like depends on
but I guess
where you come at it. Yeah.
You can test the smaller signals and then you can test the single chains.
But I think a lot of people just put a lot of this code in the view controller and it's not testable at all.
Oh yeah.
This way you can use a view model which is testable, so that you're already a step ahead.
Yeah. If you use the view, view models are really awesome. So I recommend looking into how they work, and they work with ReactiveCocoa really well, particularly with observing, your external properties. Who else?
What's the performance of this? Because you are like combining a lot of functions to have a lot of things going underground that are made by the library.
Yeah.
And how do you debug the performance of this? Because if you are making some like strong jobs on the functions or whatever, how do you find what is the bottleneck?
Again, I don't know. I was reading about that this week, and people were saying they would expect to have some performance downsides, but I think the conclusion was you can really optimize. I'm not quite sure. I think you can they've optimized it to not purely be the way that you would see. I don't know.
And another question: can you combine this in another project that doesn't use reactive programming as a whole, but using it for small parts?
Oh yeah, totally.
It doesn't interfere with the rest of the.
No, not at all. And you can really use it to start with, just as a KBO version. And which does very well. And it doesn't like explode in your face and like it doesn't explode in your face with all this functional stuff immediately. If you do that. So. Hey.
So I'm not sure whether you can answer this question, and you haven't used Swift a lot before. But so what I figured is that your code usually mostly cluttered with filter and reduce and maps,
Mhm.
and that's already built in Swift. So what I'm wondering is whether it's really useful to have ReactiveCocoa used with Swift.
But I think you're doing the math on the signal, which you can then be piped through other things. You've got to think about it like you've got
The reactive part.
Yeah, you don't get the react. So you can do mapping functions and get the
Functional, but not the reactive.
But the reactive part is mainly just observing stuff, right?
It's this.
No. There's loads of signal operators. I didn't have time to explain, but I should have. How much time do I have? Like 5 minutes?
Yeah. 2 hours.
4 hours.
Yeah.
So let's see. There's a really good example. So, whoa, it's low resolution.
Don't move it around so much.
Control Command F.
Still pretty bad. Okay. So, here, as you can't see. So here is an example. So basically, there are other frameworks that do this in a lot of languages, like RX. And here are some other signal operators that you can do. So the one I showed you was combined lasers, which. So as we drag, these top two are signal here, and these are the values coming out. So as we drag the value 1 and A, if 2 were to come before A, then this would become 2A, and 1 would be ignored. So this is besides, it's in the notes that I put on Twitter for like all the different things you can do. And there's a huge list of them, and that's really good value. Is learning how you can write these very complex logical operations in quite a small amount of code.
And that also helps with your efficiency ratio.
Right.
Short servicing also.
Exactly. Yeah. You run less code.
So do you really end up using many of them?
Yeah, I did for sure. You can't even scroll a bit.
Zoom out. Command minus.
Good idea. But then there's still more than that. Yeah. So like distinct until change. So you take a value and then you ignore any value that come back until it's changed, until it's different from the last one. Yeah. Pause signals coming through while another signal is green, and then that goes red, proving yes and no, and then start letting things through again. You really got to think about the pipes, like the Windows screensaver. Yeah. I don't know. Check these out.
Yeah, just a minor addition. What you're saying with the filter and map and the flat map stuff in Swift, that all happens instantly, and these are like rules. So you set up a signal, and you set up the next step. And if the next step is filter, that won't trigger until the first signal passes. So it goes through. It goes over clarity.
It's an Excel spreadsheet.
Let's make that discussion.
Why not numbers?
Going back to the point about performance as well, these things aren't, like you were saying, aren't actually happening until we actually need them to. So there's some functional thing about laziness. Yeah, laziness. Yeah, but also like optimizing for the tail or something. I can't remember. But you don't pull them. You set these things up and leave them, and then they only happen when necessary, not continually processing, logging the CPU. They kind of happen as and when they're needed.
Okay. Thanks very much.
Thanks.
So we